Now that I've looked into the basic routines of two-point linear fitting, I can look into another feature of it, is that I can have nonlinear transitions between the reference points. So for example, here in the remap node, I have this function input port that allows me to manipulate the transition between the input and, the minimum and maximum, so it doesn't look so linear. For example, I have this gain function that if I link in there, so I'm back into instancer points object, instance generated node editor. And so if I connect the gain node in there, you'll see that right away, there's something that's going to happen, is that the values will be clamped. This is because these function nodes, they operate in the unit range between 0 and 1. So whenever you try to wrap some values with a function, it's better to do it on values that are between 0 and 1. So if I come here and I change this gain parameter to say 0.8, see that now I have a smooth transition between A and B. And regardless of the position of A and B, I have that nice smooth fall off instead of a linear one like I have by default. So the functions that I use the most are gain and bias. You can check all the functions that are here in this functions tab or in dpkit functions tab. But so these are the ones that I use the most. This because I can have a smooth transition, or I can actually, if I do the reverse, I can have an abrupt transition, an abrupt in and out point. And then I use also the bias because it allows me to control, how the transition starts. So if I put here in bias, the default value is 0.5. If I change it to say 0.2, it will start off slow and then ramp up. Or if I put say 0.7 or 0.8, it starts off fast, but then it goes slower. So these are two nodes that are very useful to give nuances to these transitions. I'm gonna look into a setup where this can be seen better. Here in the remap example, if I plug it in here, you'll see that there's these two steps: normalization and linear interpolation. And after the normalization, it's the perfect spot to put a wrap node. So wrap node is one that transforms the values with a function. So if I put here, say, a gain node like I've put before with say 0.8, you can see that now I have the values just like I've shown with the remap node, having that smooth transition. So whenever you want to apply this wrap node after normalization, it's the perfect spot. I can also do other things like apply a curve filter. So there's this native curve node that I can use. Say, for example, I put the normalized values in the input, I put the alpha in here, and I click and I go to the alpha curve. And let's say that I put the value here at 0, 0, and another one at say 1, 1. So right away you can see this smooth transition, but I can keep adding values, even values that go below 0 and above 1. And you can see that I'm fitting this curve in between these two reference points. So that's nice. I can basically build up the type of curve and fall off or transition that I want and have my reference points to set the start and the end of that type of transition. I can also use, so you'll notice that this editor is a bit different than the usual graph editor, but I can use this curve gradient that uses the graph editor. There are some drawbacks in that, but there's also some advantages, some things that we gain with it. If I come here to the alpha curve, you'll notice that, okay, now I'm in the graph editor. And so to set up a key at input 1 with output 1, I actually have to come to the frame 25 and set up the value of 100%. So in these axes, you'll notice that I don't have any more scalar values like I had here in this editor. So here I have scalar values, here I have a scalar values. In here, however, I have frames in the bottom in the x-axis, and I have percentage on the y-axis. The most confusing one is the frames for two reasons. First, it means that I have to divide whatever value I see in here by the seen frames per second. Basically what's going to come out of here is actually the time. So when I put a key at 25, I'm actually putting a key at the scalar 1. So 25 divided by 25 equals to 1. The other issue is that it's very hard to get intermediary values. So if I put here 20.4, you see it goes to 20, or 20.5, you see it goes to 21. So the value is rounded up to frames. So this is not so great. If you want to have some value in between, it's not very handy. The advantage of this of the graph editor in here is that the pre and post behaviors. So I can also go to negative values, values above 1, etc., and have the curve be fit between those two reference points. But I can propagate this curve before and after. So let's see, offset repeat and offset repeat. The reason that I'm not seeing any change in here is because I'm using the box step node. So that means that I'm cutting off any extrapolation. So to do this normalization and see this going on, I actually have to use the remap node. So in this case, I'm going to put the input here in the scalar and my input range here. And so instead of doing the normalization with box step, I do it with remap. And now I can see the graph editor working on the extrapolated values. So it's one advantage of using the graph editor in the curve gradient. Okay, so I'm going to here to show two examples, one to show the functions and another one to show the curve. So I'm going to reset whatever I have done here. And I'm going to reveal two objects, the distance control and the distance sphere. So this sphere has on itself instances of itself. So if I activate here, you see more spheres instantiated on the sphere itself. So I'm using the point for the instances. And if I come here to the node editor, I have the base position of the instances and I have this item info with this distance control, this object right here. What I want to do is I want to use the distance of the instances to this object to control their size. So this parameter right here. Okay, so let's talk about distance. Here I have the number line, I have 0, I have 5, and I have -5. So regardless of the direction of these vectors, they have the same length, the same magnitude, which is 5. So this is what I want to do. This is the type of a value that I want, not the position. So to get the distance to something, I do a subtraction of the value that I want to evaluate minus my base. So in this case, I want to evaluate the position of the control object, and I want to put it on the base of my instances. So I'm going to subtract it. Now, I don't want negative values. I just want the length of the vector. I don't care if it's to the left or to the right. So I'm going to put here an absolute node that will give me the length, the magnitude of those vectors. Okay, so now with this, I have the distance from the instances to this object. I'm going to use a remap node to make sense out of this. So I'm going to put distance in here. So when the distance is 0, I want the scale of my instances to be 1. When the distance is, say, 5, I want the scale to be 0, so they shrink and they disappear. Okay, so if I connect this in here, you see that now the distance to the control object controls their scale. Now, you'll notice that I have some instances going into black. That's because there's some extrapolation going on. I'm having values below 0, and so I don't want that to happen. So for that, I'm going to click here on clamp values. So now as I move this away, you see that they just disappear. They don't revert. So okay, this is okay. What's the point of this? Well, I can plug some functions in here, like I've plugged before, let's say bias. And with this, say I put 0.2. You notice that now when I move the instances, they grow right away, and they keep that size, and then they fade away. So they kind of, they keep the big size a bit more. Unlike, for example, if I put here 0.8 or say even 0.9, they keep the small size longer, and as the control null passes by them, they grow really fast. So this type of nodes will allow you to give a lot of nuance to something that was, a bit linear, a bit, uninteresting, and kind of give a different feeling to a transition. So it can be the same transition, but depending on the function that you use, you can get different feelings. You can also use, for example, the gain function. So instead of being, linear transition, it feels very linear. As I go here, you notice that so you can have something that smooths that out, so as it grows and it doesn't seem as linear. So like I said, depending on the function that you put, you can have all these types of transitions, fall-offs, every time you have a gradient, to have a difference, to have a nuance in the transition. So next I'm going to look into the curve node, and for that I'm going to use this path object here, and I'm going to use this little ball as well. So I have this object animated, this big one. Basically, it's it's a sheet with a pad that it makes a hole in it. And what I want to do is I want to constrain the little blue ball X position so that it never touches the walls of this path. So for that, I'm going to link this object that is animated on the Z-axis, and I'm going to link this object Z-axis to this object X position. So for that, I'm going to use, in this case, I can use nodal motion. And so I have here the object, the path cut object in this item info. And so I'm going to use the Z to link into X. Well, if I just connect it there, it doesn't make a lot of sense. As the object moves, it's just gonna, go like that. So I need something that allows me to map this path using this object Z position. So that's why I'm going to use the curve node. And so I'm gonna connect this in here and connect this in here. I'm going to use the alpha curve again, even though there's red, green, and blue curves that you can use. I'm going to stick for now with this alpha curve. And so I want to start to get corresponding values at certain frames. So for example, at frame 0, I want the value to be 0. So I'm gonna select this key. I'm gonna put the value at 0. So I'm gonna inspect other values. So let's go. I'm gonna select this object and say that, let's see, I'm gonna put this into this top view, and I can even put this on wireframe. So okay, at frame, let's say I want to know this position here of this object at frame 15. So I have this minus 1.5. Let's say it's 1.5. Okay, so I come here to the curve, and I'm going to put a key in the position minus 1.5. Let's see where that is, minus 1.5. And now I'm going to tweak this value until it fits the path. So in this case, I'm just going to select this and go to the value. Now, actually, I've put the minus 1.5 in the wrong place. I've put it in the value and not on the position, minus 1.5. So I'm going to tweak the value until it falls inside the path. Okay, so now I'm going to check other values. So let's see, maybe I want to set up a key in here. So let's see, okay, around about here. So the value is here is minus 2.9. So I'm going to add a key with a position minus 2.9. And I'm going to tweak the value. I keep putting it in the wrong place. So and then I'm going to tweak the value so it's inside the path. I'm going to keep doing this maybe 2 more times, one in here, 3 more times, one in here, and another one in here. So let me check those. So here it's the value of the Z-axis value of this object is minus 4.3. So I'm going to put another key in here at the position minus 4.3. And I'm going to tweak this value until it goes into that spot. Okay, and I'm going to keep doing this, 2 more to go. So I'm going to move here to this frame here. So I have minus 5.3. So I'm going to add another key at the position minus 5.3, and I'm going to tweak the value. So in this case, I think it's 0. And then I'm just, I don't think I need to add another one. So from this point on, it's 0. So I'm fine. So as I move the timeline, you see that at those points, the ball is inside the path, but it starts to intersect in here, etc. So I need to adjust those. So for that, I'm going to select these keys, and I'm going to turn them into Bezier. So start with the starting point. Maybe I want the 0 to not be exactly at position 0, but be here at minus 200 millimeters. I'm going to select this first key. I'm going to put it at minus 0.2. Okay, so I think this is better. And then I want to have some easing. So as it goes in here, it's not that bad, but it needs some adjustment. Maybe I want this this inflection point to be a little bit further. So let's see, instead of having this at minus 1.5, maybe minus 1.6. Let's see. Yeah, okay, that's good. Okay, so now I'm going to start to do some easing is out with this editor. And so let's see if I can select the control handles. Sometimes it's a bit tricky. Okay, nope, minus 0.2. It's definitely tricky at times to get the Bezier handle going. Wow, this sucks. Minus 0.2. Okay, finally, that was annoying. Okay, so I have some easing going on in here. So the ball, it's not touching the walls. Here, maybe I needed a little less of easing, or even a bit more. Let's see. Okay, now on this transition, I need quite a bit more easing. So I'm gonna make this big curve. So it goes there. Still needs more easing. So like so. It's still intersecting with the wall in here, so I'm going to give it even more, maybe less on this side. So I'm going to unlock the control points so that I can move one side independently from the other. And so with this, maybe this needs a little bit more. And okay, this needs more. I can unlock the control point. Okay, and now I'm going to do this transition here. So I need to give some easing in here. Let's see, I'm also going to unlock the control point. So let's see, it goes like this and like so. So I'm going to put more easing and maybe less in here. Let's see. So as I move that, you can see, okay, so it's a better transition, still even less in here, almost linear. Okay, more tangency, and let's see. Okay, yeah, so that looks okay. And now this one is a straight line. So I don't need any easing here. So I can put this here, or even if I can point it, make it point to the next key, and it's linear. So okay, good. Just going to adjust this initial part in here. So it's not so good. It's touching the wall in there. So let me see what I want to do in here. So maybe I put this in a little bit. Let's see. This is a good starting point. In there. Okay, it doesn't touch the wall anymore. It's just there's a little slight thing going on. So I'm just gonna tweak it here. Okay, so this is a nice way to do things. You want to tweak something to something very custom. This is not something that you could do with a function. 2-point linear fitting. This is very custom shape. So this is where the curve node shines. Okay, so I think this one is done. You can see that now this is constrained as I move this object. So if I animate this object, you see that the little ball doesn't touch the walls. It actually might touch the walls just because of one thing, is that the Studio Live doesn't update the viewport fast enough, so it doesn't, to look correct. So if I move this really fast, it's not going to look good. I have to move it slowly so that Studio Live can keep up with the updates. But anyways, if I slide, the timeline, you can see that everything works out fine. Now I can even go further, and I have here this object called path handle, and I can make it point to the if I come here to the motion options, and I use the little ball as my target. So if I disconnect that there, you see that I just have the ball doing the path. But if I come here to this object and I select as the target the little ball, now I have this handle sort of constrained into that narrow path. So it's a nice way to do a constraint, because now every time that I move this, I'm basically constraining this handle. So this concludes the nonlinear approach. Next, I'm just going to look into parameterizing a function.